or 3 pages of work. It was crazy. It was insane. It like nearly had me in tears. I just was not happy. And Mrs. Dagan comes along, and she's the one who tutored me through all of my early math that I did to get my math degree. And she comes walking in to the table where I was sitting, and she said, well, here, why don't you just do it like this? And she used just like Algebra 1, high school, Algebra 1 skills. And here I am in a calculus class in college with pages of work. And she did it like in 4 lines. I said, but that's not using calculus. She said, well, you don't always have to use calculus, even if it's a calculus problem. Some of them are solved with just basic algebra. So I said to my students often, if you don't know where to start, go back to the beginning. Go back to simple things. Simple rules for multiplication. What are the rules for multiplying? You have 2 numbers that you multiply. What are the basic rules of multiplying? Yeah, well, negative times a negative makes a and a makes a negative, and positive times a negative makes a negative, and positive times a positive makes a positive. So keep that in mind when you solve seemingly unsolvable problems. Number 20. There's a solution. There's a lot of solutions. But I'm not going to just hand it to you. You have it.
Yeah.
Don't tell anyone. I'm serious. Don't. There's no learning that takes place if you're just simply told the answer and allowed to walk away from a problem. You got it.
Yeah.
Awesome. It's pretty funny, isn't it?
Yeah.
It's sitting right in front of your face. You don't even know it. But when you don't know where to start, go back to the beginning. That comes from a great Jeff Daniels movie. Golly, what is this? What are we supposed to do with this thing?
Just align it so that it's easier to solve.
Okay, so if we're going to simplify, there's no solving because there's no equals, but if we're going to simplify it, that means we should probably make it with less symbols. So that implies combining like terms. So start at the beginning. Are there any other t's? Okay, so if you take 42 and 16t and you combine those, you get how many? 58 t's. Cross them out. Any more t's?
No.
Okay, then I'm just going to work across. Any more p's?
Yes.
3p over
3p over 8, which combining those, you may say that's challenging because this is a fraction, right? But, you know, this is something that we hit on real early again next year, but you have seen. This is the same as that. And it's the same as, oh gosh. I think those are the 2 ways we really need to look at them. Let me just look at it like that. So this is like 3 times p divided by 8. 3 times p divided by 8. We can still rewrite it that way. It's 3/8 of a p.
Isn't it negative 3p?
Yeah, so we'll just look at this as the addition of a negative. So now you have 3, and then you take away 3/8, and you're left with?
Why?
What?
No.
So you have 3 p's, and you're going to take away 3/8 of a p. How much do you have left if you take away a whole p? 2. Well, now we're only going to take away 3/2 or 3/8 of a p. So we're out here at 3p. We're going to go back 3/8. Here's 2p. 2 and 5/8. 2 and 5/8 p. Cross them out. Now, subtracting a negative is the same as adding. But is there another y?
Yeah.
There's a y squared. Remember with algebra tiles when we would do it, it'd be like this, and this would be y squared because it's y by y. So y to the second power cannot be added to y. They're not like. So I'm going to take the higher power and I'm going to write it first. And then this is plus y, we're gonna write it next. Now we're left with 45. So that's as far as you can get it. Because none of these have the same variable any longer. Or the same variable with the same power. That's 20. 21's the same issue. So x over 2 and negative x over 2 in number 21, those might be a little dicey. So we should think of this as the same as 1/2 times x. X divided by 2, you get half of an x. You take an x, you cut it in half, now you have half of it. If you have a negative x over 2, that's the same as negative 1 times x over 2, which is the same as a negative 1/2 of an x. Those are the same. Just different ways of writing them. So I'm gonna, what now? So I'm gonna leave you to your own devices with 21. If you have a question on it, try to do it. I'm not gonna do it again for you. I just did one for you. You're gonna use the same ideas. Look for the variables that have the same power and are the same variable. Combine them. Keep in mind that subtraction changes the sign of what comes after it. So subtracting a negative is the same as adding a positive. If it would be adding a negative, that would be the same as just subtracting. So like this right here, we could write this as the addition of negative 1/2 times x, or subtracting 1/2 times x, either way. Anybody else get 16 figured out yet? You got it? Good, don't tell anyone. Anybody else? That's a good one to keep pounding away on. But, first off, I gave you a lesson master yesterday. Could you find that? And I gave you some graph paper the other day. You may wish to have more, I'm not sure. Let's see.
And when we,
So that lesson master, remember I said I'd tell you
the puppy.
what I thought we should do? Yeah, we got more puppy pictures, so we got better ones than that. Here? Is it 10-1A
No.
One B.
or 1B? Okay, so that's this one. All right, so here we are. So any work that you do in terms of graphing, I'd like you to put on full-size graph paper with reasonably large graphs. Go big when you do this. What I have here, if you take a look, it says this lesson master, number 3 and number 4. That's all I'd like you to tackle on this. Just question 3. Oops. This one here, question 3. So that's what, Dottie is on the 15th floor of the skyscraper, Lottie is on the 87th. Yeah, Lottie Dottie.
That's a lot of floors.
You'll see when we get further into this textbook series, it gets funnier and funnier with the names. But
They
anyway.
started running out of ideas.
No, they don't run out of ideas. I think they have people that just sit around with their feet up on desks, playing darts on the wall, saying, oh, I got another name. Then they write it down. Sit and daydream all day coming up with them. So number 3 is a situation where you have these two people on different
Down
floors,
Reagan.
and they are traveling through the skyscraper at different speeds. They're changing floors at different rates.
Is a flight a floor?
A flight is a floor, yes. A flight of stairs goes between 2 floors. You betcha. So if you went down, if you were on the 87th floor and you went down 3 flights, you would go down 3 floors. Up in a skyscraper is positive, down is negative. Then, let's jump ahead, number 4. It's just numbers. Yeah. So that's just like, create a table, put it together. There's no lottie-dottie there. You can choose which to do first. It's up to you. But either way, I think what I'd like for you to do is, I'd like you to use the lesson master sheet as a reference for the information. And then, for example, all of the work that goes with number 3, do that on your piece of graph paper, so your piece of graph paper is complete. So it shows each of the equations, it shows your graphs, and then if you make a table to create your graph, do that on the graph paper as well, off to the side. So then you get the whole thing in front of you. You can see the whole process on one sheet of paper. And then either flip it over or take another piece of graph paper, whatever you choose. But please make your graphs big. Use a straight edge. Do them in pencil. I'm going to let you work on that for a while.